Hello everybody, good morning, good afternoon and good evening. My name is Elke Hilscher. I'm the leader of the chemical group as part of the research and development department at KWS. I will give you at first a short introduction about the development of the KWS BEETROMETER, what we have developed over the last years. At first, I will give you a short look, and if you see such a BEETROMETER looks like very simple. In the end, we have a conveyor belt, we have a special developed chopper, and we have the measurement system based on a near-infrared spectroscopy. But the system looks very simple, and so the system is also very flexible. And this allows us to make quality analysis in sugar beet about the value chain of the quality of the sugar beet. We have the analysis on the field. Such as BEETROMETERs installed since almost 10 years on harvester. This allowed us to analyze sugar beets directly during harvest for the main quality components. As next, you can use such a BEETROMETER in a receiving station in a sugar factory, for instance, or in a quality lab of a sugar institute. Also, therefore, we have respective calibrations. And last but not least, you can use such a BEETROMETER also on a mobile system, on a trailer, for instance, and can, with this system, analyze stored beets. And we have respective calibrations for washed beet, for unwashed beets, for fresh beets and for stored beets. The development of such a system has any challenges. The most important challenge is the heterogeneity of the quality components. And if we look in the first, sorry, this was my mistake. The next advantage is of our BEETROMETER, it can mainly short the steps in the analysis. In the normal way in the sugar factory, we have the delivery, then we take a sample, we have the washing process, the thawing process, pre-processing, preparation of the filtrates and the analysis. With the development of the KWS BEETROMETER, we are able to replace any important steps. So we have, of course, the delivery of the beets, and we have the washing process of the sample, what we have taken, but all the other steps are completely replaced by our KWS BEETROMETER. And now I come to the most challenge if you develop such a method. The most problem is what I said, you had an irregular distribution of quality components within a beet. We have done a special trial 4 years, 5 years before, and have analyzed the different segments of a beet, what you see on the left side, different colors, and the segments they marked different content of sugar. And you see, you have alone in between in the head of a beet and the tip of the beet a variation of sugar content of up to 3%. And if we then look in the middle of a beet, then we have here, if you look outside of a beet and in the center of the beet, a variation of sugar content up to 2%. The next problem what we have not this irregular distribution of quality components within beets, the same as also between beets. As an example, from a uniform field, more than 450 samples were taken with a sample size of around about 12 beets. And we had a very high variation. We seen in the middle we had around about a sugar content of 16%, but we had a variation in the single samples between 13.5 and more than 17%. It means more than 4% between the different samples. Then the question is that I got all the time is, if you compare your results of the BEETROMETER with a typical price sample, how big is the difference? Then I ask you as an analytical scientist, what is the real value from the sample? For instance, we have the delivery of 25 tons. From this 25 tons, we take a subsample of around about 40 kilograms. We make our pre-processing, then we take a subsample of 26 grams, and in the end we make a filtrate and we use only few milliliters for the analysis. What we know from the analytical point, the biggest error comes from the sampling step itself. It means the first sampling is if we take a subsample of 40 kilogram. And the next problem comes with the sample preparation, brei production. Brei production is such an important process. You have to include all parts of the beet and you have to include all beets of a sample. In the end, if you do this in the right way, you have around about 1.5 kilogram of a brei. And in the end, we take only 26 gram of this brei and make our analysis. And from the whole filtrate what we produce in the laboratory, we use then only few milliliters. This means that each sampling step, the susceptibility of errors increases. If you think on the application of near-infrared spectroscopy to develop a method, then we have to think on the sample preparation, since we have the irregular distribution of quality components within and between beans. We have to think on the measurement of the whole sample and need an homogenization of the sample. And last but not least, we need multivariate calibrations for the prediction of the quality components. As we in the beginning of the development, what we have seen from previous analysis with NIR spectroscopy, all of this work were based on a brei sample, and this is clear, since the production and the sample preparation of a brei sample is a well-known approach and a well-accepted worldwide method for sugar beets. The problem is it's the right one for a subsequent wet analytical chemistry, but the problem is such a brei sample is not stable. We have a high instability, and what happens if you produce such a brei sample within few seconds, you have a change in the color from like white to dark brown. And we have not only a change in color, we have also immediately this beginnings after processing, we have an influence of the sugar content. The main problem is of such a brei sample, this is very wet. It's clear our sugar beets consist to 75% only of water. And what happens is you have a very fast development of a thin liquid phase on the surface of such a brei sample. And if you then respect the rules of near-infrared spectroscopy, you know the near-infrared wavelengths are completely absorbed by water. It means NIR light is not able to penetrate through water. So if you make a measurement on a brei sample on the surface, you analyze only few microliters of the liquid phase. If you put your brei sample, for instance, in a cup from glass and make then a measurement on the bottom, then you analyze also only few grams. So it was clear, to the application of near-infrared spectroscopy, brei is not a solution. Therefore, we have developed a special shopping system, and this allows us to process between 15 to 150 kilogram of beets in only few seconds, and we have included in this processing a mixing and homogenization steps of the samples. We have no liquid phase on this shop beets, and this is important, the next one. And since this works so fast, there is no oxidation and browning before the measurement of the shop beets. This was the basis to develop the method for near-infrared spectroscopy. Today we have a uniform sample presentation in pressure roll produced from all the shop beets and even surface. We can analyze the whole sample. There is no further sampling step inside, since the whole sample and the shop beets of the whole sample are moved under the sensor, and in a distance of 200 mm to the sample surface, every 40 milliseconds a spectrum is scanned during the shop beets are moved under the sensor. So in the end, from a sample size of around about 40 kilogram, we have more than 400 spectra that were analyzed in 15 seconds, and the whole process, including sample preparation, takes 20 seconds, not more. This was an overview about the work process of the Vitrometer, and now I will give over to my colleague Elton Cavallo.
Thank you, Elke, for this wonderful presentation. Weren't you impressed by this? This took a lot of time, 10 years of hard work, yeah? Well, this makes my job as a business manager so much simpler. Well, because a good product sells itself. Say, assume like me you were equally impressed with Elke's presentation, you trust KWS as a reliable partner within the sugar beet industry, and you want to move forward to the 21st century. What would be the advantages for you? The first advantage that you would have is the Beetrometer is a complete system. It's an industrial unit that is ready to be used. It can be installed within an existing warehouse. It can be installed in parallel to your operations. Initially, of course, you need to win the trust of your farmers that this system is giving you accurate results. We have the possibility of installing this system in parallel to your existing system, and thus you are able to compare results and win the trust before fully transitioning into this system. The second advantage of this system, again I want to highlight, the technology behind the system is very complicated, but from the design, operation and maintenance perspective, this is as simple as it gets. There are few moving parts, it's robust construction, it's easy to operate, and it involves minimum maintenance at all points of time. And finally, it does the job for which it has been built. It gives you accurate results. In fact, every sample of beets that is tested has a minimum of 400 readings. That means one reading every 40 milliseconds. KWS over the years has over 5 million samples collected. That means we have accurate calibrations for all kinds of beets and can give you accurate results in 20 seconds only. So it serves your need. But then, a lot of you will ask, we have our existing systems for the last 10 years, 20 years, sometimes 40 years. Why do we still need to change? Here's why you should change. We have studied this system and we have tried to improve it. With automation, we have few human errors and sampling errors. The entire process is standardized, thus giving you reliable and accurate results. The second point that we have done away with is the use of chemicals. A lot of these are highly polluting and need specialized workers on a seasonal basis to handle them. And then this also leads to a lot of maintenance costs. With our NIRS system, we do away with all these requirements. The third point, agronomy. What happens with existing systems, because of the high cost of testing, we tend to reduce the amount of testing, sample testing that we do. Here we say, go in for more testing, get accurate results and reward the farmers who bring in beets with high recoverable sugar content. This improves agronomical practices within your farmers and improves the overall efficiency of your factory. Because when you have beets with high recoverable sugar content, you have a more efficient factory. And the final point, KWS, as Jörg has already mentioned, has been in business for 160 years. And with the Beetrometer business, we plan to be here for a long time too. That means every year the calibrations are upgraded into your system. All new features are updated via software update. And we have a very robust system which will run for years. We would also want to show you that every Beetrometer unit that is manufactured undergoes a rigorous factory acceptance test. So here it is for you, the factory acceptance test, a short video. Hello, my name is Elton Carvalho. I'm the Beetrometer Business Manager at KWS. Today we are going to conduct the factory acceptance test on the Beetrometer unit at Puch, the manufacturer of this unit. Come along! During this test, we check the Beetrometer for robust construction and design, smooth mechanical operations, safety features, software integration, and finally, calibration and accurate measurement. Today's factory acceptance test was successful. This Beetrometer will be delivered to our client Canal Sugar in Egypt. To learn more about this system, please feel free to reach out to us. For the next stage of this Beetrometer event, we take you across the Atlantic to our colleagues in the US. We have Mr. Dwayne Bernardson live from the American Crystal Sugar Company. The American Crystal Sugar Company is one of the first customers of the Beetrometer. Over to you, Dwayne.
Hey, thanks, Elton. Thanks, everyone, for joining. Happy to be able to be part of this event while we're bringing you the remote part from here in North America. I'm joined with Mitch Kennedy, the Quality Lab Superintendent at American Crystal, and we're sitting on the dock at the Quality Lab, so we're right in the heart of the full operation. Harvest got done a little early here at American Crystal. They had good weather, but we want to be able to show you how the system works. So we put together a short little video that will take you through the Beetrometer in action here at American Crystal. So let's play that video. We put together a short video of the Beetrometer installation at the American Crystal Sugar Company Quality Lab in East Grand Forks, Minnesota. They operate 6 identical lines, with each line being able to measure tare, whole sugar, dry matter, and recoverable sugar. After washing, the beets are weighed again clean so that the percentage of tare can be calculated. The scale opens directly into the Beetrometer chopper, where the sample is processed. Once chopped, the sample is collected on the belt below until enough material is ready to be prepared for measurement. The belt moves the sample under the roller, where it is leveled and compacted to maximize the area for good scans. From there, it passes under the sensor head, where a scan is taken every 40 milliseconds. These scans are then filtered, averaged, and a prediction for each calibration is saved, along with all the spectra data. A quick, easy, and reliable process. So Mitch and I just want to talk a little bit about the system here. As the video mentioned, it talked about how the measurements they had used at American Crystal. American Crystal has been using a quality payment system since back in the 1980s. And at that time, they went to a wet digestion measuring whole sugar, sodium, potassium, amino N, and to get their recoverable sugar for their payment, because their growers are paid for how much white sugar they as a grower are able to put in the bag. This is the second campaign that the Beetrometer system has been used here at American Crystal. So I guess before I answer the question, I just want to make sure everyone knows we're practicing good social distancing here and following through. That's why we don't have the masks on. But Mitch, would you share an overview with your lab and the process you use here?
Yeah, thanks, Dwayne. Good morning, everyone. So what we do here, as the video said, we run 6 identical lines with the KWS Vitrometer system. Annually, we run about 190,000 samples, split into 2 different time sections. Typically, during main harvest, we'll call it, we run 15,000 or so a day. But like I said, we do divide it up into two sections. We call it pre-pile and a main stockpile harvest. Pre-pile runs from about mid-August to the end of September. We typically take about 10 to 15% of the crop, which equates to about 2.5 million tons. We can do this on 1 to 3 KWS lines. We do about 8-hour shifts. And that runs, like I said, till about the end of September. And then starting October 1st, we do main stockpile harvest. This, we just run until we're done, till all the beets are taken out of the ground. We run 24 hours a day, 2 shifts. Typically, we have about an hour downtime to do any maintenance, clean up. But like I said, we run 2 shifts. The goal for the day with this new system is to clear the dock, we call it. With the old wet digestion, the goal was to not fall behind. But with this new system, we can run samples quickly, but we are still accurate, reliable, and consistent data. So we call it clear the dock, which is impressive when you consider on good days, we can harvest over 1 million tons of beets, which equates to about 15,000 samples per million tons. So, at the end of the day, it's to provide the most accurate, reliable, and consistent results for those growers, those shareholders. So,
yeah, and it has been, it was really nice this year for as fast a harvest as you had. That I know for you, it felt good being able to get in and clear the dock. So how did your campaign go for you this year, Mitch?
Campaign this year went as well as could be expected given our current world situation. COVID really it contributed staff-wise. The last 2 harvests were difficult harvests. So it kind of created a compound effect on our staffing. We did have people not feel comfortable in coming back this year just because of COVID. But our goal was to create a safe and safe environment for everyone. And I think we did accomplish that. As you said, we had a very quick harvest. We had typically you could run out as long as October and in November. This year we were pretty much done in 14 consecutive days. So October 14th, we were pretty much done. We ran about 180,000 samples, pre-pile and stockpile harvest combined. But overall, things went very well. The nice thing about a quick harvest is you can push the equipment and see how everything works. And things worked wonderfully this year. So very happy with this year's results.
Yeah, Mitch, you bring up a good point. That's one thing we talk about. COVID, we compare with all of our colleagues across the world as far as that situation, and in the U.S. COVID has actually been similar across the U.S. beet production areas. We're listed unfortunately, in a hotspot here in Grand Forks right now, and I know it's similar for other people, and you brought up some good points as far as how you were able to manage that situation and just help the comfort level. I think that was a big part. One thing you talk about, or you mentioned, you use a lot of temporary help.
Yep.
And with running 2 shifts, I think that can prove a little bit of a challenge at times.
Yep.
So I know your day crew is more of what would you say, your veteran crew? Or?
Our day crew is our veteran crew. Yep.
So you have some people that have a fair amount of time in here as far as working on the quality lab.
No, those individuals typically have anywhere from 15 to 40 years experience. So those individuals really help out the process. As you said, COVID has proved difficult, but with the new system, some of the thought that went into that is we could reduce the temporary staff we need. We really didn't get rid of anyone per se, but it reduced the temporary staffing we did need because it was beginning to get very difficult to find help. COVID kind of compounded that. So, the new system, you have less people working, but you can also be spread apart. So that really helped the comfort level of those individuals that were here. And that was a big benefit. Maybe not one that you intended to have on any normal year, but it was a great benefit this year.
Because how many staff do you use now, and how did that compare to what you had before?
This, we typically, on a normal year with this system, we'd have about 65 harvest employees compared to over 130 for the wet digestion, the old way of doing things. So it cut it roughly in half. But, with this, on the inside, we call it, roughly 4 to 5 people per line. Now we can do 1, if not 2 per line. So it really helped things out on the social distancing aspect.
Yep, and I think, that brings up the other point is people talk a lot about automation and how automation, with automation, you're able to reduce people. And it's one thing I know you guys have said, you've reduced people, but really you still are those highly skilled people that you've been able to maintain those and keep them on, which helps you. one of the questions we, always comes up as well is how does it go on the grower side? The growers feel comfortable with the data you're providing them, and what sort of questions do you get from the growers in regards to that?
As you said earlier, this is our 40th year of the quality lab payment system. So we've had 40 years of trust building, which really helps during this transition. And there's a lot of research, time, and effort put into switching over. Just to make sure the results were reliable and consistent compared to our old way of doing things, and things were very consistent, and that really helped being transparent with all the growers. The most questions we get aren't even about the quality per se, it's about the tear conditions. Why is my tear high? And we were able to implement a new feature which put conditions with each beet. So that really helps with those questions, but you very rarely get questions about sugar content, recoverable sugar. So they are pretty comfortable with the results we get.
And just for people, if you haven't heard, I know we have a video about the system as well that's on our Vitrometer website with American Crystal and kind of that transition. We worked hard to work with you as far as calibration. We continue to work on the calibration to keep that current. So one of the things that you do is look at the beets from around the area, where different production areas, where they come from, and kind of take those through. So we keep that calibration that's live, and I think that as well has helped you as well as management feeling that the system is reliable. Yep. And good results.
As you said, it's a living, growing thing. So you keep adding to the calibration, and it keeps getting better and better. So yeah, so you have one line here, like you said, we've used that, and it's really helped bring that comfort. We did work, especially with our first installation, making sure we put together lines so that we're able to compare. It's really hard you can't split samples, so it's working through that process. Elka does a really good job in helping us understand that and get through that as well. If we look at some of the other benefits, I think we talk about labor. I think the other side is probably sustainability. Yep. How do you feel? You got a system, when you compare the system you were at, which I think that was one of the fears, was sustainability of the wet digestion. How do you feel on the Vitrometer system now? I am very happy with things. It's some of the questions you get are maintenance. The old system, you have a lot of variability with that system. A lot of moving parts, a lot of things can break down. Your KWS system, mechanically, it's a lot simpler, I guess we'll call it, in a way. There's a lot less moving parts. So the maintenance aspect, it's reduced that. So that's a huge benefit. Just on downtime alone, our old system, you'd have to calibrate every 30 minutes. With your KWS, you still calibrate every 30 minutes, but it's for 23 seconds compared to minutes with our old system. And with your system, as you can talk, you're kind of calibrating with each sample. You have your confidence factor, which you can go into if you'd like, but I'm very happy with things.
So yeah, so just to kind of clarify, Mitch talked about the calibration. They do a reference sample every 30 seconds, which really takes in the potential changing environment of the system. One thing that probably hasn't came out and we haven't pointed is they run 6 lines. So we bring those lines in and we do a bias adjustment so that it provides that confidence that each line is reading accurately and really giving you the same information for each. And I think that was one of the benefits that you saw as well.
Thank you everyone for joining us today. This was really wonderful having all of you. Catherine, our marketing manager, just mentioned to me that we had over 100 participants from around the world. This was really fantastic. As you can see, myself here and Dwayne. Dwayne is in charge of the business and the entire North American market, and myself in the rest of the world. So if you have any further questions, just feel free to reach out to us. We have personally emailed you before this event and we would be more than happy to address any of your issues.